me open the Python right now.
Yeah.
Okay, should I start with the problems with the pseudocode because I wrote that one on paper?
Whatever, it doesn't matter. Yes, whatever you prefer.
Okay, so the first problem with the pseudocode is that when they first ask for the inputs, it's outside the loop.
Okay, so you write it. Just can you send it to me?
Okay, let me send it to you.
Okay. So I understand that it's a, I mean, you wait until the class to send me to show me the homework, but and I understand if we take Saturday and Sunday, it will be challenging for you. So, from Sunday until the next Saturday, I think you still have enough time to do the homework and send it to me a bit earlier. So
Yeah, I do.
we need to maximize the usage of the class, please. It's for your own benefit at the end.
Yeah. Okay, can I quickly go down and bring and get my phone?
Yes, you can do that. Yes.
Okay, so I'm back. I'm taking the picture now.
Okay.
Okay, so I've sent it.
Okay. Okay. I see only one line.
No, the two.
Okay. And okay. Can you, yeah, give me a second. I need to download it to be able to see it. Okay. Yep. Okay. The asking for input is outside the loop. Input before loop. Can you translate it?
Yeah, so like they're usually supposed to ask for the input during the loop, but they did not. And they got inputs before the actual like loop.
Okay, give me a second then. Let me. So, are we speaking about the same exercise here?
Yeah, yours. Yeah, that's what I'm talking about.
Okay, so which line are we talking about here that you need to? Okay, so which line again? I'm missing. So if I
Uh,
say 1, 2, 3, 4, 5, 6, 7, 8. So this is the number of lines. Okay, now explain to me,
yeah.
please.
So line six is supposed to be in line three.
Okay, here.
Yeah, there.
Okay, okay, good. Okay, what else? So in short, you want to say that we should put input mark here. Am I right?
Yeah,
Okay, what is the reason for that?
because the inputs is wait, am I wrong? Uh,
Don't doubt yourself. You just give me your reasons. You don't doubt yourself. You are on the correct road. Just give me your reasons because again, programming is about reason. If you reason correctly, it means that your logical thinking is okay. So don't doubt yourself. Just continue what you're saying and give me your reason.
okay. So I think that it's not supposed to be asked like they're supposed to. Let me look at it again. Yeah, I think you're supposed to input the mark before your while and do loop.
Okay, fine. I accept that. Okay. So if you did not input the mark here, what will happen to the remaining of the code?
It just won't run.
Okay, accepted. And so when you remove the input mark, which is currently line number 6, if you remove the input here and just put it here, so it means that the loop will be running without an input. Is that correct?
Yes,
Okay, so if you run without an input, how are you going to provide the marks that is going to be totaled here? Any idea?
uh, no, not really.
Okay, so typically um, you provided input mark because input mark here must have an initial value that can be tested against this condition. If he did not provide a mark here, uh, the program will tell you that he have no idea what mark is. So when you input it like that, you give mark a certain value, an initial value. It could be -1, it can be 0, it can be anything. And then while we are looping here, while we are inside the loop, because most probably we'll be inside the loop for quite a long time, we will need a mark to be inputted. The reason for this code is to, okay, can I know your average math score from 100? How much?
Sometimes 80, sometimes 90. It really
Okay,
depends.
and English.
Oh, English, that's usually 90.
Okay, and let me see, history.
I dropped history.
Really? Okay, what about geography?
I dropped geography too.
Okay, computer.
Usually 90.
Okay, that's good. So if I want to total these 3 marks, if I don't put an input mark here, which is the only way for me to add this. So if I want to add these 3 numbers, what should I do? I put 80,
You're going to add the three of them and divide it by three.
but this is if you want to get the average, but I just want to get the sum.
Oh, you want to get the sum? I thought you said average. All you have to do is just add the three numbers.
Okay, that's good. So if I want to add, so I need to get the 80 first from the user. He need to key in 80. After he key in 80, I save it, and then I take another input from the user. And after I add the second input to the first input, I take a third input from the user, and I add the third input to what I have added before here, and that will give me the sum at the end. So if you neglect totally input mark, that will actually not allow you to input any marks from here. So it will be the only way to input a mark just one time. So if you input 80 here, so that will be the only time you enter something. But we need you to actually sum a number of scores, not only one mark. So you need an input inside while. Okay. And there is another mistake in the code other than the input.
Yeah.
The arrangement of the code here is wrong. Okay. So actually, again, I think you did not have a chance yet to look into the slides. Am I right? From the previous class.
I looked at the slides, but very briefly. I think it's on my way to school.
Okay, but the same code you have taken before, actually. I have given you the same code before. And I have explained this code exactly before to you in the previous classes. So I am not very sure. I find you smart, but I have no idea what is the issue here. Um, you make me really not sure what I can do. But okay, I know you like theoretical part more, but
Yeah.
this does not help if you want to become a programmer, or even if you want to pass the exam. I mean, on the short term, you want to pass the exam first before you even think about becoming a programmer. And possibly, if you want to join computer science, maybe you will take the A level. So that is more and more programming. Okay, now let me share.
Yeah.
So I think you can see. Have you studied anything about chapter 3?
Hardware.
Mm-hmm. Yes.
Yeah, a little bit.
Okay. Then tell me, what is the advantages of no, let's start with the CPU. What is the CPU?
CPU is the central processing unit, which is a type of integrated circuit on a chip.
Excellent.
Uh,
Okay. And what it does?
it processes arithmetic calculations and logical decisions.
Okay, that's good. And so it execute instructions and it handle data. Can we say like that?
Yeah,
Okay. So if we can we consider Python and pseudocode instructions or a data?
yeah. I'd say instructions, honestly.
Okay, so it's instructions and the instruction need to work on a data or not. So if your instructions is actually to say z equal x plus y. So this is an instruction. But at the end of the day, x have a values stored in it, y have a values stored in it, and you need to do the arithmetic operation here and store the result into z. So I mean, this is a few steps that need to be done actually. But anyhow, so yes, we handle instructions, but we still need to deal with data. And the data is either saved on the chip, on the microprocessor itself, or it can be saved on the RAM. Okay, so do you know the von Neumann architecture and what is the benefit of it?
Von Neumann architecture was like the benefits of it is that it's closer to memory.
No. What else you know about it? About von Neumann architecture?
They have registers.
Mm-hmm. Okay. Yeah, I mean, you are what you're describing is not wrong, but the von Neumann architecture solved a deeper problem than what you are saying. So I mean, initially, the programs that was written to be executed on the computer need to be manually loaded, which means that before the creation of hard disk and permanent storage, they got the programs installed on tabs. So these tabs, it is read.
Oh, okay, okay. No, I
Okay,
thought you were saying something, but then I realized you weren't saying anything because, like, I didn't hear anything.
really at
But
all?
don't worry.
Nothing? You didn't hear
Yeah, I
anything?
think it's just my Wi-Fi.
Okay. So this tab was actually having the program installed on it. So so it means that the computer was not general enough to be able to execute multiple programs at the same time. No, it wasn't. So every time they need to do some program, to run some program, they need to load it manually. And the the program itself was loaded into kind of tapes. Okay. So the volume and again the tape cannot be accessed um, in a sequential manner. Okay, so it means that also once we read the program, it cannot be stored on the memory. So we needed a way to store programs inside the computer itself. So the von Neumann come with a way that make the CPU have direct access to the memory. That is one thing. And yeah, add um, add the capability of storing instructions and data inside the memory. And he allow the execution of programs in a sequential manner. We will look into more details in the coming slides. So what I want to say that yes, when you said that there is registers in the von Neumann architecture, so yes, this is true. But the whole design was to solve certain problems. The certain problems was that we was not able to store programs inside the memory. Now we are able to store programs and data inside the memory. To achieve that, von Neumann created control unit, ALU unit, and a few registers. So is that the only registers available in the CPU? No. Actually, we got more.
No.
But this is what you study at the moment. So can you tell me what do you know about the CU?
Control units coordinates the flow of data around the system by sending control signals to other parts of the CPU. Yeah, it should be CPU.
As a part of the computer system in general, but not only the CPU,
Yeah,
because it
yeah.
have to deal with the RAM. What about the ALU?
Arithmetic and logic units. That
Okay,
one is the one that processes, I mean, performs logical decisions and completes arithmetic calculations. Yeah.
okay, that's excellent. What about MAR and PC?
Memory address. Okay.
Yes, yes,
MAR,
continue.
MAR.
Yes,
Okay. Memory address register. I think this one stores the address of where the data is to be next, where it's supposed to be like next sent to.
send to what?
Sent to the other parts of the CPU.
Okay. Uh, Not really, but okay. I mean, you nailed 50% of it. What about the PC?
Increment by one every time an instruction um is performed.
Okay. MDR.
Stores the data of where it's next supposed to be sent to.
Mm-hmm. Okay. CIR.
CR, current instruction register.
ACC.
Yeah, accumulator.
Okay.
Wait, wait. Okay, no, don't worry, I remember now.
So, okay. Actually, excellent. So, what you mentioned about the ALU is actually correct. Um, okay. So, what about the RAM?
Random access memory, it stores instructions or data or applications that are currently running.
Why do we need to load programs from the hard disk to the RAM?
Hard disk saves it like permanently, and RAM is also volatile. So hard disk is what we use when we're done with the information.
Can the CPU access data stored in the RAM?
Um, I'm sorry, could you repeat your question?
So can the CPU access the data in
Oh
the
yeah,
hard?
I can, and it accesses it faster. That's another reason why we use RAM.
It's only faster.
And it's more direct because like if you look at your CPU architecture, like when you build your computer on the motherboard, your CPU is very close to your RAM. So it can also access like it can use all of those extremely fast buses, and if you bought a motherboard that has this dual channel, I think is faster.
Okay, actually, yes, you are excellent in the theoretical part. Excellent, excellent. Okay.
Thank you.
Um, yes. So, but okay, my comment on your answer here when you talk about MAR, MAR contains the address in the memory where the CPU either reads from or writes data to.
Oh, okay.
Okay. MDR holds the data being transferred to or from the memory location specified by the MAR. Okay. So it doesn't say about next instruction. So it's a current instruction. Okay. Control unit, you already answered that. What about address buses, please? What about the address bus, data bus, and control bus? Can you tell me what is the address bus for and why we need to use different buses, address and data?
Um, where we use address bus. I think that's like I know it's unidirectional and it contains the address. Okay, it contains address of memory locations. Okay.
Okay. And what about the data bus?
Contains the data and is bidirectional.
Okay. Okay. Let me see. Let me see. Okay. What is meant by the stored program concept? This is an exam question.
I've not heard of stored program concepts.
So the stored program concept is introduced by von Neumann, which means that before the von Neumann architecture, we was not able to store programs. We have to load it from tabs, and we was not able to store it in the memory. So it means that you read it in a sequential manner, and if you want to really read it again, then you have to rewind the tabs to be able to read the program again. But when the von Neumann actually created his architecture, we are able to access different places in the memory without the need to wind and rewind the tabs, because we are not using tabs anymore. We are accessing the memory in a random and in any way that we want it, actually. So we don't need to wind and rewind the tapes anymore. So okay, now can you tell me? Okay, I think you already know the role of the program counter. So can you tell me? Can you describe the role of the control bus, Emmanuel? Did you disappear again? Wow. So what happened, Imran?
I don't even know.
Luckily, I didn't continue for long without asking about you. And then when I kept asking and reply, then I check, I find myself alone. Wow. Wow. Okay. So what was the last thing that you heard from me? Emmanuel. 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 Uh, Emmanuel.
Yes, sir. I'm sorry, I didn't hear what you last said.
So what was the
But my
last?
Wi-Fi is normal now.
Yeah, okay. Now, what is the last thing that you heard from me before you left in the first
You
time?
were talking you were talking about stored program concept, but I didn't get to hear you because of the Wi-Fi.
Okay. So, okay. I mean, tell me first what do you know about the control bus, and then I will explain to you again about the
Control
short.
bus is a bi-directional bus that sends instructions from the CU to the other parts of the computer. Yeah.
Yes, yes, correct. Okay. So the stored program concept is actually designed and created by the von Neumann architecture, the guy who created the von Neumann architecture. And the point here is that we are able to store programs inside the memory. Previously, we don't even have memory. We are actually we get executing the programs and the instruction directly from tapes. So these tapes have to be wind and rewind using human, with assistance of human. So we are not able to access memory, different memory locations without winding and rewinding the tapes. Now, with the von Neumann, we are able to access any place in the memory without any issues. So I want you now to read that, please. This is the official answer.
Okay, instructions and dates are stored in the same slash main memory. Instructions fetched and executed in order, one after another in sequence.
Okay.
Do you want me
And
should I still continue?
no. So,
Okay.
okay, let me just, so I will send you more exam questions on this part, but let us move here. So what do you know about the fetch, decode, execute cycle?
Oh yeah, I've heard of it. It's how the computer actually I heard about it a long time ago. I don't really know how to explain it.
Okay, so this is a cycle for actually executing any single instruction, any single line of code that you write to get it executed by the CPU. We need to do a fetch, decode, execute cycle. So we do that cycle in milliseconds. Okay, and so that is how, I mean, we are doing also this kind of cycles, I would say billions of times because of the current processing speeds. But this is the basic. So we started with the fetch, decode, execute, and then we get it faster and faster by time because of the capabilities of the CPU. So in the fetch, you go and bring the data and the instructions that is stored in the MDR. Okay, this is in short. Typically, we will see that into more details. And then once we get the instruction, so actually it starts like that. You use the MAR, which is a memory. You put an address in the MAR, and the control unit fetch whatever in the address specified by the MAR. And then it fetch it to what? It put it where? Into the MDR. So this is the address and this is the data fetched to us by the CU control unit. Okay. And then it means that
Yeah.
once we already got an instructions and the not instructions, instruction, only once a single instruction, and we already stored it here. We need to decode that instruction. Means that we need to find this instruction is going to do what on which data. So this is the decoding. So you fetch the instruction, you decode it, try to understand what it does, and then you start to execute it. So how is it executed? The computer know that for every fixed instruction that we have, there is a certain steps of control signals that can be issued by the CU to execute that fixed instruction. So let us see how the instruction looks like. So a single instruction, can you see here this 3?
Yeah, I can see those three. Z equals X plus Y.
I mean, no, that is not what I am pointing to. You are not looking at the screen, are you?
I am. I thought,
So I'm writing here. I mean, do you see my
oh,
pen?
load 10. Sorry. I wasn't, okay, yeah, load 10.
Okay. So what I'm saying here that this and this and this is 3 instructions. This, you can write it in Python, but this is a high-level language. In reality, this should be translated into an assembly language, which is a low-level language. And this is an example of a
Yeah.
low-level language to just add 2 numbers and store uh, the result into a third place. Okay. When we are dealing with assembly language, we actually dealing with memory addresses like here. 10, 11, and 12 is actually memory addresses. Where is the memory addresses? Is actually here. 10, 11, and 12. So typically, we will add the content from here to here, and we will store the result of those adding these 2 into this memory location. How I say like that? Because I see here store 12. Okay, so we will go into more details, but definitely we will take that into steps to actually work more on your pseudocode and Python skills. So I will stop here and I will start. Okay.
Yes, sir.
Okay, so I would say, can you read that instruction, that exercise again, please? Emmanuel, can you hear me? Emmanuel, 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 can you hear me?
Sorry, sir, I got disconnected again. What did you last say?
Can you read this exercise, please?
Okay. Test your understanding iterative questions. Write a program in pseudocode that does the following. Ask the user to enter a number iteratively. The square of the power of 2, the number will be need to stored in an array. The program dynamic, no fixed size array like this. Declare square num array colon
Your voice
array
is
1 of
in and
integer.
out. Okay. Okay. So what did you understand so far from this, what you read?
That should just make an array.
Okay. And you need to store something inside the array or no?
Yeah, the powers of 2.
Okay. Good. So if I want to do that, what is the steps that you need to take to be able to store? So can we analyze together? Whenever you see enter a number, it means that you need to use the word input, the instruction input. Uh, these show me that there is an iteration. So when there is an iteration, it means that there is a loop. When I see enter the value 0, it means that, so, okay, we should halt when the user enters 0. So this is a condition that will end the loop. So again, programs are developed step by step. We don't want to complicate our brain with too much information. So first, I can see that I'm able to write the portion of the loop. I take an input from the user, I make a loop, and then I make sure that I exit the loop if the input number from the user is 0. This is the first thing I ever think about. When you do like that, it guarantees you every line of code that you write in the exam, you got a mark for it. So if you thinking about the whole program to make it correct, that is actually not an excellent way to do things. So did you understand what I said?
Yeah, I did.
Okay, so how to write a loop? So if we look here, and I ask you now, how to write an initial loop? We know that we need to have an input, we need to have a loop. It is not wrong that you start writing things in the screen, even not organized. It doesn't matter. Start with the way you need to start developing your own style of solving programs, so, or exercises. So now tell me, what can we write? If we want to write a loop, how to do it? Which loop
I
we can
think
use?
it would be an end while loop.
Okay, so you want to write a while loop, also can. While, do, end while. Okay. Okay, what condition that you want to put here?
Um, um, if it's not equal to 0, then they will.
Excellent,
Um,
excellent.
oh,
Okay,
really?
yes, yes,
Wow.
yes. But this, yeah, because this is the condition we talked about just now. If the input from the user is not equal 0, we should not run. We should not run whatever in between the loop. Yes. So yes, you continue like that. So again, how do you think we can take an input from the user? So you build the structure of the loop. Now, guess to me, where can we write the input? Where we take an input from the user?
Did you see like inputs?
He didn't say like input. Okay, we can.
No, I'm asking, I'm not saying anything.
Okay, you're asking again. Can you repeat again a question, please?
No, I didn't hear what you last said, so I was like, I wanted to like repeat it.
I mean, what I want to say that as we see from the exercise, he's telling us that the user should input. So sorry, not input. Enter a number. Enter a number means input. This translates to input command in pseudocode. Enter a number, and it seems that this number need to be inside the loop because he need to enter a number not only one time, a few times. So that when I see enter a number and it is in the iteration, it means that I need to keep taking a number from the user. So that also can give me an indication at the start. I can be wrong. It doesn't matter. Not when you're learning programming for the first time, there is no guarantee that you always know where to write your code or instructions. You can make mistakes. There is no issue. The more you practice, the more you know the tricks, and you know your brain get used to that. So we need to write an input command to take an input, to take a num. So we said that we already decided that the num should always be taking, it should be the input from the user. So if the input is not equal 0, we will continue. Okay. So how do you want to write, or where you want to write the input?
Um, okay. So what I'm going to do is I'm going to add an input before the while.
Okay. Should I write like that? Input num, or you want to put input something else? Emmanuel, did you
That's
disappear?
all I want to input for now.
Okay, so this is the maximum input that you want to provide. Emmanuel, can you confirm, please?
Can I quickly use the bathroom, like very quickly?
Okay, sure.
Okay. Okay, I'm back.
Okay, good, good. So, Emmanuel,
Yeah.
okay. Um, so did you hear about there is something called Chinese New Year?
Yeah, I know about it.
What do you know about it?
I know it's a huge celebration, and like it's also a huge celebration in the US as well. And they
Really?
used to make Lego sets. Yeah, I heard that's a big celebration in the US. Like some schools, they do holidays because of it. And they now
Mm,
release discounts on games.
interesting. Okay. And did you attend that ever?
No, I've never attended it, but there are lots of like, and even whenever you play like online video games, usually lots of like banners and rewards.
Mm, okay, that's interesting. So, in your country, are you able to purchase things from outside, or it is a bit tough? So, are you able to purchase things from China directly to your house?
Oh yeah, from China, yeah. It's easier for China compared to US and UK.
Wow. Okay, that's interesting. And you are a game lover.
Yeah. But I stopped playing because of IGCSE, but the moment I'm done, I'll start again.
Do you write games or you just play games?
I just play them.
Okay, interesting. Okay, so okay, now you said to me that this input is enough, right?
Yeah.
Okay. And may I know here? what this guy is saying here. He said, ask the user to
Ask a
enter a
user.
number, and then the square of the number will need to be stored in the array. So if this is the array name, any idea that can come to your mind, how can we store a number inside an array in pseudocode?
Um, I didn't hear what you last said, but I realized that that there's something.
Okay, let me repeat that again. So what I want to say, the exercise say that you have an array and you need to store the number, double the number that the user input into the array. So how do you think we are able to store the number, this num, inside this array?
Um, I think you have to add a counter in the beginning, and you have to declare. Okay, yeah, you have to add a counter
What is the usage of the counter?
just to like so the program like counter will be equal like no counter will be one.
Okay, you're smart enough to detect that. Okay, but okay, but again, I still hoping that you revise the slides, because if you revise the slides, you will know that we already take how we can actually assign something to an array. We took that we have 10 student names, which is strings, and we are able to save them inside the array. So how we do that? We use an arrow, and we use the array name. And we put here the value that this is, of course, if it is a string, the value that we want to store inside the array. But since this is not a normal variable, this is just an array. So and the array have many positions. So we need to specify the position in the array that we want to store this value. So typically you have the array like that. 0, 1, 2, 3. This is if it is in Python. If it is in pseudocode, we always start the arrays from 1. How I know? Because we started here the array from 1. So 1, 2, 3, 4. Okay, now this is an array of integers, which is square num array. You store the first number here. After you store it here, you want to store the next number here, not here. So who decides that? The position. So your positions should start 1, or your counter should start at 1. And every time you get a new input from the user, you need to increment that position. Is that something that seems understandable to your brain or to your thinking, or it's a bit complicated?
No, it's a bit understandable.
Really? I mean, you don't have to hide from me anything. You need to be
No, no,
really
no. I actually like understand it.
okay. So, okay, what I want to say that, but again, so one solution that I find with people, with the students that I have, who doesn't really like, not like, but they are, I mean, they are not very strong initially in programming. But don't take that as a that I'm telling you that um, I'm putting you down. No, but one of the solutions that I have seen, and it seems that it worked with one of my students, um, who doesn't like programming, is that you start to memorize code. So if you want to see that code, so you told already this portion correct, this correct you have said, and this correct you have said. This is also correct. You have said to be able to actually compensate for the parts that you didn't know, you need to start memorizing code, but based on the understanding, which means that, okay, this code is responsible for inputting or storing a value inside an array. The more codes that you write and memorize, that will improve your skills. It takes time. It's not something that I can tell you it will happen over a week or two. No, it takes time. So this is like a math. We keep trying different exercises until your level of expertise actually improve. So okay, now can you tell me
Yeah.
please, these three lines inside the loop, what it does and why? So did we see that line before inside the loop?
Um, I think we have.
Okay. Do you see how he used here the word counter? This is a variable, and the variable start with one. And after every time he inserts something inside the array, he increments the counter. Why? Because like I told you, this is your array. You insert in one, you should not take another input before you you point your array counter to a different position, because it means that if you didn't, you will keep inserting only in one position in the whole array. The whole array will be empty. Only one position will keep getting an input from the user, which is not correct. We need to fill in the array with different values. Okay, so that's why we need to increment the counter, so that after
Yeah.
it points to one, it then points to two, and then it points to three, until we enter zero here, then our loop will terminate. Did you understand what I said?
Yes, I do.
So can you promise me to show me next class about this um, pseudocode that we took? Can you please?
Yeah, I promise.
You promised, but then you already disregarded the promise that you gave me last chance. I
Actually, I have
still.
my mocks on Monday.
Oh, so you give me a
Yeah.
strong reason. I'm not able to tell you anything. Okay. Okay.
But I'll try, because I think I'll have some, when I'm studying for computer science, I'll just read it.
Okay. So now have a look, please. Can you read what is this?
Totaling in pseudocode refers to accumulating a sum of values over a sequence.
So this is the student mark, and this is an array that's called student mark, and it have a list of numbers. So if I want to sum all these numbers, there is a fixed algorithm for that. The, the fixed algorithm is an example of it that also as a start, please memorize that after the understanding. So we put the total equal 0. And then we put the class size depending on how many students inside. So we decided that the class size is 10 in this case. So we need to make a for loop that runs 10 times. How I'm deciding that? I'm starting at 1 and I'm ending at the class size, which is 10 in this case. So I run from 1 until 10, which means I run this for loop or this statement for 10 times. So what this statement does, it actually gets a number from the student mark, which is from this list. So the number is stored here. Every time the loop runs, I will take a number from the list. So the first time I am starting at counter equal 1, which means that here will be 1. We call here the value. Sometimes we call it the element. Here, we call it the index. So index is a position. At the position, there is a mark, there is a value. So the value is a student mark in the exam. So here is an index. What is the value at the index is 75. So to get the value out, we have to put the index in between square brackets. We mentioned the array name, which is a student mark. It have 10 values from 1 until 10. This beside the index. So when I say 1, I'm referring to the index. When I say 10, this is the end index. 1 is a start index. So again, when I first run, I run with the counter 1. So I'm getting which value? I'm getting the 70. So I add the 70 to the total. Initial time when I run, the total equals 0. Are you able to follow up with me?
Yeah, I'm able to follow up with you.
So, okay, I add 0 plus 70. The result is 70, and it is stored inside total using this arrow. So the next time I run the loop, the counter gets incremented. Instead of 1, it points to 2. So what is the value at 2 that we get? When this is 2, so we get 75. And so here's total is containing 70 at the moment. And this student mark at index 2 have 75 inserted inside it here, or stored inside it. So the arithmetic addition, it becomes adding 70 plus 75. We add this, which give us how much? You slept.
75.
How much?
75.
75 plus 70 give me 75.
Oh, 145.
Okay. So at the end, 145 is going to be stored inside total. So total will contain 145. You increment your counter. How much is your counter now?
Um, do you mean like what's 75 plus 70? I mean 75 plus 80.
No, I didn't mean that. So it means that I lost you somewhere. Okay. Okay. So I think the concept of arrays is still difficult. You don't grab it yet.
I grab a so.
So. Okay. So what do you understand about arrays or lists? So I can try to build up on top of that. Emmanuel, did you disappear?
No, I'm here.
Okay, so what are you doing? I'm asking you. What do you know
Um,
about arrays? What do you understand about arrays?
they're like an ordered list.
Only like that? Just only like that?
They also have positions.
Okay. So can I say that supposed to be every variable in the memory have a separate memory location. So if you have x equal 10 and y equal 20, and then you said that if you do that in Python, it should work. So X have 10 here, Y have 20. And when we say X plus Y, it means that we have to add 10 and 20. What should we store at Z?
30.
Okay, that's good. So again, this is a single variable, this is a single variable, this is a single variable. When we are talking about arrays, we have, I mean, every one of those have its name, but sometimes I need to make loops and to make a smart code or smart program to actually how to say um, do do automate tasks for me. I don't need to make only addition between two numbers. I need to make addition between 10 numbers. How can I do that with a single variables? So if you have 10 numbers that you want to add, so you add y to m to n, and so you have to keep mentioning different variable names. But that is not how the programming works. That is not easy to write 10 variables. So that's why instead of reserving 10 variables inside the memory, we decided to use a concept called lists. So the list allow you to reserve a different or dynamic place in the memory up to your choice. You say to it, reserve for me 10 numbers or 10 places in the memory. So from 1 until maybe 100 or 100 places in the memory. So all these places in the memory will be used to mark student marks. I call all these 100 places in the memory only using a single variable name. And then if I want to access the first location, I use something called index. So I said at the array or the list that's called student marks, give me the position 1. The student mark, give me the position 2. So when I do that, it somehow ease my pain if I am dealing with 100 values at the same time. I only need to mention the index. Is that somehow clear or still confusing?
It's clear.
By 80% or less?
80% and more.
Okay, okay. So, but now, do you understand anything about this code? I feel that your understanding for this code is somehow not perfect, right?
Yes, sir.
Um, you understand it like 20, 30%?
No, I understand more.
Okay, okay. Hopefully, when we do this with Python, it should be slightly better. Anyhow, okay. I still need to come back to this code again. But now, I'm depending on that you didn't study that before. You didn't show me your answer for this exercise.
Oh, really? Let me send it now.
I mean, did you write it in any compiler for Python?
No, I just typed it.
Okay.
Let me send it. Okay, I'm still looking for it.
You cannot find it?
No, I'm looking for it. I've been downloading lots of past papers, so my file system is a bit disorganized right now.
You still cannot find it.
No, I found it, but I noticed that there's some things wrong, so I'm just correcting it.
Just no worries. I mean, send it and we can discuss about it. Or even if you have access to it or a picture to it, just share it and we discuss about it.
Okay, let me send it now.
Emmanuel, I understand that you are used to studying on the theoretical part. I'm just reminding you again, pseudocode and Python will actually not gain access to your memory and your skill set, or some part of your brain called procedural system, unless you really practice it a lot. So okay, pi
Yeah.
equal 3.142. Okay, that's excellent. Radius equal float. Okay. Okay, that is actually good, but did you get external help?
No,
100% sure?
I'm 100% sure. The mistake I made is that I times it by three instead of like exponentation.
Okay, so even if you don't know how to put an exponent, then you just write radius multiplied by radius for 3 times. So that can also do the job. But okay, it's acceptable. Acceptable. Let me. Okay. So you still can see my screen, right?
Yeah, I can still see your screen.
So can you see that? Can you see this is an answer? So this is supposed to be the answer um, when you don't know the exponent yet. Okay. Let me. I know you might not remember the case of,
Oh
but
no, I remember case of, other case, then the options and outputs, then end case.
okay, excellent. Do you know that we do not have case in Python? We have
Yeah, I know
in
that.
Java, we have in Java something called switch, which is almost similar to case of. The problem is that if you need to write, so I mean, the pseudocode case of it's actually like a gift from God, because if you would like to replicate that in an if-else statement, that will be like hell. You have to write a lot of code, and it's called a nested if, and that's horrible. So here you got the choice when if it is just right case of grade, the variable name, if A just do, B just do, and if you need to write if, it will be so much complicated. So if again in Python we do not have case of, so this is how we do it in else if. So did you see that else if before in Python?
Yeah.
Really? So do you understand that this
It's
code
the
is
else if or elif. Yeah, yeah.
Elif? Yes, yes, it's true. It's Elif is short for else if. So you have to understand that Python is a new language. There was languages before that, C++ and Java and so on, and we use else if. So Elif is short for else if. But at the end, yeah, this is the case, else if. So if it is A, if it is not A, then else it can be B, else it can be C, else it can be D. The last else will be invalid input. So if none of the above is true, we will just print invalid input. So you understand now that these two code are equivalent. Hello,
Yes,
hello,
sir.
hello, 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 Mr. Emmanuel, can you hear me?
Yeah, I can hear you.
Okay. Just read this and I will provide it to you as an exercise homework. I will not do
Ask
it here.
one odd or even. As haven't we done this one before? Ask the user
Similar.
for a number. Yeah, ask a user for a number. Determine if the number entered is an odd number or an even number. Print out the results. Tips: when we divide a number by two, the odd number will have a remainder of one, and an even number will have the remainder of 0. You can check the remainder of a number by using the percentage symbol, e.g., 5%2 will give you 1.
Okay, task 2. Um, I think this I will give it to you as a homework, and the previous task 1 also I will give it to you as a homework. So good luck in your mock tomorrow, and see you
Thank you.
next Saturday. Do I need to remind you about Saturday?
No, no.
Okay, then good luck tomorrow. See you then. Bye
Thank
bye.
you. Have a great day.
Same for you. Bye bye.